what I got today is something that I actually had the ability to test ahead of time, which I was very well appreciative for that, actually, because I had a little bit of say and input on a little, not much, just a little design say and input on certain things. And I don't know how much more I can actually say on that, because at the time I was under an NDA, but at this point the NDA is not covered anymore. So I'm not going to go into what input I had or what changes I recommended personally. Like I said, it wasn't much. I just like testing things and, you know, try to make things work properly before they're released if possible. I don't mind doing that kind of work in my spare time. And this is one of the items that I've received to actually do that. This is the AU3D, or it's being produced by AU3D. This is called the Ritocco. Is that what they're calling it? Doesn't really say the name here. One of the tips came out. Ritocco. So we'll go with Ritocco. Okay, we'll call it what it is. It's basically a soldering iron for 3D printed objects. And if you own a 3D printer, I'm sure you've ran into a situation where, like I mentioned in the beginning of the video, you end up doing an air print because your filament stopped feeding for whatever reason through the extruder. The purpose of it is for doing repairs, for doing modifications, but I can burn anywhere from polycarbonate to nylon to PTEFE to ABS to PLA. So I grabbed a sample of just about every little filament I could think of at the time, and a few sample pieces too as well. This is actually made out of polycarbonate. I believe this is PLA, but this is one of those perfect things. It's a hinge to the front of the door of my printer, and this is one of those items that you just may have, I don't know, pulled on it slightly too hard, and before you know it, oh no, you broke your hinge. Now, do you really want to go through reprinting this whole entire thing again? Granted, if I printed that originally with 100% fill, instead of it being hollow in the middle, I probably wouldn't have been able to break it as easy. But I didn't, so afterthought. Now, do I want to print out this whole entire thing again just for this one piece? Or can we use this tool to fix it? Well, there's only one way to find out, and that's to take a closer look at this tool here. So this is your hot swap pad. This is what you're going to use to actually pull the tips in and out while they're still hot. And we have the Ritocco actual iron here. And basic, simple function, you know, 2 buttons. Not much to it at all. Real lightweight. I should bring up the fact of how light this is, because this is actually extremely light. Luckily, I just happen to have the scale up here for a different project, so let's go ahead and take a look at the weight of this. So the total weight of this is actually only 38 grams, and I believe this looks to be about the heaviest tip. So with the tip in it, I like this tip. This tip was not included in the beta sample that I had. I'm really interested in trying that one. Goes up to about 44-45 grams. Really lightweight, not much to it at all. Now it comes with 4 different tips. So we have 4 different tips it comes with. We have a nice, really small, sort of well-pointed tip here for detail work. We have something that kind of resembles a knife to maybe do some fine cuts or layering. We have your basic kind of wider soldering iron tip, and the way these irons are actually made and designed is these are the ones with the ceramic heater that's actually built in to it, so it only gets hot where it needs to be at the very tip of it. And this one, which I didn't have to play with during my testing, which is a very unique kind of a cup. Now you could probably use it to scoop, or my guess is you're supposed to use this round piece here to flatten, basically. So what else do we have in the box besides those items there on top? Let's pull it out and take a closer look. We have the power supply. it seems to be a nice, beefy, heavy switching power supply. I've already checked the power supply out. It is a switching power supply. And then we have a couple of screws and some nuts in the bag. What looks like the holder for the actual iron itself. Seems to have a really nice hold there. I like that. It also comes with the instruction manual. Unfortunately, I left that downstairs. So I'm going to have to grab that to go over the instructions. And let's pack the rest of this box up and move this aside. And as always with a lot of the AU products, it comes with a very nice, heavy, sturdy metal stand, which is always a good, nice one thing. Also, a nice thing that they added here was this little piece, which makes perfect sense because this actually screws onto the stand. You can screw it here in the back onto this stand. So to put the stand together, it actually comes with a little instruction manual just to put the stand together. But of course, I'm fairly certain I've put a couple of these AU stands together previously. I think I can figure it out. Looks like the stand's fairly simple to put together. Let me go ahead and see about what size screws we're dealing with here. Some bolts, some nuts, some screws. Grab a driver. Yeah, this is just going to be too small. This is more for electronics. Let's grab a regular driver for something like this. So your black screws are actually going to thread into the front part. There we go, there's the holder. And you do want the holder facing out with the lip coming out like this, because this is going to support the weight of it like such in the back here. So some people have put this on reversed, that's why I'm mentioning it. And for your tip holder, we have two little metal indentation notches here that will fit right into that one. You want the solid flat base at the bottom with the holes in the middle and the top, like so. And we're going to line these up with the two holes in the back. And this is going to be a simple screw and bolt and nut. So the station, nice and easy to put together. We'll take our 4 tips here, put those in the back, and as a matter of fact we'll take my favorite tip here, the real small micro tip here, and we'll actually just plug that in. It's really that easy. That's all there is to it. And insert it. Done. The last and final step, of course, is providing power. So let's go ahead and give some power. As soon as you plug it in, you'll notice it comes on with a blue LCD which says off. It's got a slight flicker there. That's because of the refresh rate of my camera. I actually don't see that flicker in person, so just a FYI. One button turns it on, 100 degrees Celsius. Next button, ABS. It's a preset temperature for ABS. Next button, PLA, and 100 degrees Celsius again. Now once you're at the feature you want, let's say you're doing PLA, you go to PLA, you wait 2 seconds, and you'll see a little heater come on over here, and this tells you just activate the PLA and it will start heating up your tip. To turn it off, press both buttons at the same time and it's off. Now let's say you want a custom temperature for, well, why would you want a custom temperature? I don't know. Polycarbonate. Nylon requires a higher degree of temperature to melt these filaments. So we can go over to 100 degrees Celsius, and we'll give it a second for that heater to come on. And once it comes on, we can take that and hold down the up or down to adjust the temperature we want. I believe it will go up to 400 if I'm not mistaken. You know what, as we're doing this, let's go ahead to ABS. I'm going to insert this because ABS will give you a nice temperature. And I'm only pulling about 26 watts. Not bad. And the weight of it, still very nice, ergonomic fit. Feels good in the hand because there's not much weight to it at all. I guess you really don't need much, nothing heavy duty, so to speak. And I'm pretty sure we're hot here at this point. Let's give me something to test on, just to see if I was hot. Oh yeah, definitely hot. So I'm going to put this back in the stand. So we'll show that we have some heat going on here. I'll just do a little insertion through it, like so. Just put a little hole in there, really easy. And as far as cleaning the tip, we're just going to use the normal soldering mesh for cleaning any plastic residue off of it. Always do this in a well ventilated area. Now you can see we're hot here, and you just saw me melt something, so you know we're definitely hot. We know it's hot. We just melted a little piece. This is what the hot swap pad is for. So we can take the tip very carefully, wrap this thick piece of rubber around it, like so. And we're going to pull it out. Now instead of waiting, this is why we have a metal, this is why it's metal in the background, so it doesn't melt anything. Instead of waiting, the little display went over to all dashes here. Instead of waiting for one tip to cool down to move on to the next one, well, this is cool, so I'm going to grab it with my hand. But if you're swapping constantly between different tips and you don't know which one's cool and which one's hot, I would always recommend getting into the habit of using this hot swap pad all the time. And then you can insert the new one, adjust it into the angle that you'll be most comfortable using it, and as soon as you do that, it goes back over to ABS and you see that little heater kick on there again. And I'm going to hit both buttons and turn this off. And there we go. Now we're off, and we'll throw it back in the stand. So really simple, basic functionality. Okay, so I was just checking the temperature tip of the product here, and I had it set for 230 degrees, and it was just bang on 230, but I moved it slightly. Some of these probes can be very, very delicate. Let's see if I can get it back up there. Nope, apparently that's the wrong direction. But I found the temperature to be very accurate without any need of recalibration, which was nice. In ABS and PLA mode, they have what's called levels, where you can actually change the actual levels. Let me go ahead and turn this off here, show this to you real quick. So if you go into ABS mode, and give it a few seconds, and you'll notice that the little bar for the heater comes on over here. And ABS seems to be set about 260 degrees is where I measured it, and then it has levels. You can go 1 all the way up to 10, and then you can go down -10, so you can kind of fine tune and adjust it while you're working, depending on how thick the plastic is, what the material may be. What I found is each level, it doesn't say this in the manual, but I was reading about 6 degrees difference Celsius on each level. So one level would have been 266 degrees, level 2 would have been closer to 275 Celsius, and this is what I was observing. So we'll go back down to 0 and we'll see what ABS reads at. Let's see if I can get this back on the probe here. Boy, these things can be touchy sometimes. There we go. So I'm using the quick exchange rubber mat, so the mat underneath it needs to actually heat up too to get an accurate reading. So if I was to hold this for about another minute, it will slowly climb up to 260 degrees Celsius. But I've already done this, so there's no need to do this again. So let me turn this off. What I'll do is I'll actually go over here and we'll set this to manual. Wait for the heater to kick on for that little bar again. There we go. And I'll adjust this down to 100 degrees Celsius. This may take some time to cool off. But another thing I'd like to note is I've been using this now, measuring these temperatures for about a good 10 minutes. So that brought up the curiosity factor of how hot does the rest of the device get? Well, let's take a look at it here while this tip cools off. So you can see where my hand is about 32, 33 degrees Celsius. Nothing extremely warm. In fact, it doesn't start heating up until it gets to that metal round clip, and then of course the rest of it. This isn't going to read perfectly accurate either, because, well, quite frankly, it's there we go, it's better. It's metal, so flares don't like to read shiny metal materials, but the unit has stayed cold in my hand the whole time using it. I have not had a problem with it for the last 10-15 minutes. It doesn't seem to be getting extremely warm or anything like that, so very nice to see that. I'm going to shut this off. Now we should be set about 100. There it is. You can kind of see it there. Let's go ahead and measure it. Wow, look at that. That is really not bad at all. 4 degrees off. 5 degrees. Not bad at all. In fact, that margin of 5 degrees off may actually be dependent upon the accuracy of the meter itself. But if you trust the meter, like most of the AE products in the past that I've tested, it gives you the option to calibrate it. So let's go and turn it off. So for calibrating, what you want to do is go into advanced mode. So there's ABS, PLA, that's advanced mode. Wait for the heater to kick on. And we're going to hold this down, both buttons, for about 10 seconds. So now I can take it 3. So that should put it right about exactly at 100 degrees Celsius. So we'll turn it back on. And let's check it again. And again, you can access that just by holding both buttons down. Ah, beautiful. Really, really good. So now we know each level in ABS and PLA changes at about 6 degrees Celsius. And you have the option of advanced calibration just by simply holding down both buttons. And you can change that advanced calibration quite a bit in either direction. And once you have it to the point where you want it, all you simply have to do is let go of the button, count to 3, and it will save it. And there it is. Your setting is saved. Okay, so another nice feature that it has is the sleep timer. Now to access the sleep timer, you want to hold the button on the left and hold that button down while plugging it in. And you can see it automatically went to 30 when I plugged it in there. I don't know if you saw that, but as soon as I plugged it in, it was at 30, and because I held that button down, it was counting down. So by default, I believe it's set for 30 minutes. We'll put it down to 1 minute, and we'll go ahead and turn this back on to 100 degrees Celsius. And you can see how fast that warmed up there, how quick that counted up. And let's see if I can hold this still for about a minute. There it is, SLP. So SLP is your sleep mode. Hope you can see that. So while it's in sleep mode, the temperature should be coming down. Let's see if I can probe it without turning it on. And then as soon as I move it, you can see it just changed to 100 degrees. And the tip is heating up again. So I like that sleep option. I like to see these advanced features on something so light and so small. And also really easy to access. Both buttons again turns it off. We're going to unplug it. We're going to hold the button on the left, plug it in, and we're going to change the sleep mode to, I don't know, I think I'm good with 15 minutes. We're going to wait a few seconds. It will automatically save it, and there it is. Now sleep mode is on 15 minutes. Holding the right button and plugging it in does give you the option to change between Celsius and Fahrenheit for those that prefer Fahrenheit over Celsius. So it's also nice to see that feature as well. Wait 3 seconds, it will save it. Now in addition to calibration and sleep mode, it has some other advanced features in here as well. They're calling these advanced options. Mode 1 is the default mode. The user has access to all functions and features of the device. So by default, this is technically in mode 1, what they're saying. Mode 2 is where you can set it to PLA only. The user can only use PLA mode with level adjustments. So the 10 level adjustments that I mentioned where you can adjust up 10 and down 10 are still available in mode 2. Mode 3 is ABS with the options of the level modes, which is 10 up or 10 down. Each level is about 5 to 6 degrees Celsius. And then you have mode 4, which is a single temperature mode only. Only a single set temperature is allowed, no other temperature options are available. So mode 4 is basically saying you're basically sticking it at a single temperature and it's not user adjustable and it's locked in at that temperature. Let me see, how do we access these advanced modes here? Now we're going to try to access both buttons again at the same time and see if we can change these advanced modes. There we go. I'm going to count it up to 110 again, which is the passcode. I don't believe you can change the passcode. That should be it. And it didn't seem to give me the option. Passcode. Oh, I messed up. Okay. We'll try this one more time. So what I was doing wrong is once I have access to enter the passcode, which is both buttons, plug the power in, count up to 110 or 110 for the passcode. Once it's on 110, hit both buttons again to activate the advanced mode selection. So we're almost there. Now hit both buttons again, and now I'm in mode 1, mode 2, mode 3, and mode 4. So I'm going to do ABS, and I want mode 3 to be adjusted at 230. So this sets my default for ABS to be 230 with my 10 level adjustments. To let it save, you just wait 3 to 6 seconds and it will automatically save where it left off at. There it is. But some nice little advanced features for such a small, light unit. I was actually impressed to see some of those features. Sleep timer, Celsius Fahrenheit change, lock it into a single temperature, lock it into PLA only with the 10 levels up and down, or lock it into ABS only with the 10 levels up and down. And with the PLA lock, you can actually set the default temperature, and the ABS you can set the default temperature to as well. I don't believe there is a way to change the passcode. Nope, there is no way to change the passcode, so the default passcode for all of it is going to be 110. Now we have that all set. Let's go ahead and get the meter out of the way. One thing I will recommend, most definitely recommend actually, is if you already have one of these and you've been using it for solder, put a clean one in, because you want one for plastic now and one for solder. I don't believe, by the feel of these tips, I don't think you want to end up getting any type of lead solder on this tip, because it may actually corrode the actual material that this metal tip is made out of. So I wouldn't recommend getting any type of lead solder on this, and if you use the same cleanup dish, then there's a good chance that you're going to end up getting some lead solder on there. So I would get a second one just for this unit. You should have one for your soldering and then one for your plastic. Not to mention, I actually did make that mistake when I was trying to take the temperature of the probe. I cleaned this with one that had some solder on it, and I ended up getting solder on this, and I ended up soldering my heating temperature probe. I ended up shorting it out actually, because the solder transferred from cleaning this to the probe. So I didn't realize I had gotten solder on that tip until I had a hard time getting the actual temperature to take correctly with the K thermistor probe, and then I realized what had happened. So I took the one out with all this solder, which I have a lot of solder on both sides, and put a nice clean one in here. So this is now just for the plastic soldering iron. So let's see what we can do as far as using this in a practical manner. One of the common mistakes or errors of a 3D printer is when it gets to the very top of a round head where it might not extrude enough. You see how it kind of left some holes in here? So Yoda's got a holy head. So we're going to see if we can actually use this unit to fix Yoda. So for this one, the tips cool down fairly quick. As you can see, this is actually worn, but I wouldn't recommend that. You got this here, always use it. So for this one, I'm going to actually try and use this curved ball here, and I'll turn this to an angle that I'm comfortable with for this little curved ball, and we'll turn it on to ABS. Actually, to tell you the truth, I think PLA will be hot enough. Yoda is printed in ABS, but I think PLA is going to be more than hot enough, because I don't want to melt through this. I'm not cutting through this. I'm just trying to fix this up. So I'm going to keep the temperature a little lower on purpose, as we try to fix Yoda's head here. As a matter of fact, with the 10 level adjustment, I'm going to go back 10 levels and let it cool down. And this way I can kind of test it as I go, and if I find out I need more heat, I can just simply reach up here and adjust it up. So we're going to start off at -10. Maybe even take this piece of plastic here. I'm sure you have some test parts laying around, and you can see the lines because this wasn't done in a high resolution. There it is. So if I can melt the lines flat here and kind of fuse these together, and yeah, you see it is doing it. Yeah, I may want to, this is tedious, you have to go really slow, and then if you go really slow you actually kind of melt too much. I want to be able to swipe right across it real fast and fix Yoda's head. So we're going to, I'm going to count up to PLA default temperature. Remember, I was at -10 there. I'm going to test it again once it warms up and see how it handles. Let's take these lines again, see if we can fuse. Rub back and forth real fast and see if that kind of fixes it. Because we don't want to melt a new hole in Yoda's head. We want to patch the hole and just kind of fuse some of the plastic together. Now it seems to be heating up quite a bit, maybe a little too much. So I might want to step it back just a little bit. So with a little bit of practice, you'll figure out what temperature is best for what you're trying to do. So I'm going to step it back to about -4. Let this cool down a little bit. And let's see if we can fix Yoda's head. So without adding any new materials, I'm going to cool this down and make sure the thickness is still there. Your best bet, or my best bet, would have been to actually cut a piece of black off and simply clean up, add a little plastic to it and fuse where that hole was. But as I mentioned, I forgot to bring up some black ABS with me, and that was my fault. Maybe I can steal a little ABS off of this part here. Let's use the scooper and see if we can scoop just a little bit of plastic. There we go. And I'm going to shift this little bit of plastic down onto Yoda's head. Aha! Well, there we go. We just stole a little bit of plastic. Yoda no longer has a hole in the head. Look at that. I don't have to reprint it, and it looks pretty good. So we're going to hot swap. There we go. So I'm going to choose this guy here. A very fine point. Now that it's plugged in, it's going to start heating up. I'm going to turn it to an angle that I'm more comfortable with to use it as like a pen or a carving tool. I know Yoda's supposed to have a little line here that runs across to join these two parts, and I kind of smoothed out everything, so let's use this little small tip to see if we can add some of that line back without recreating the hole that we patched up. Oh, there you go, look at that. So we brought the definition back into the lines on his head. I like it. Biggest thing with working with different colors is to make sure to clean your tip very well before going from one color to another. You don't want to transfer plastics. So the last few little questions that I have here is, we know how ABS works. I'm sure PLA will work just as well, but smell a little better. Yeah, smell a lot better. Smell like sugar cookies. So we got ABS, we got PLA. This will go up to 400 degrees Celsius, which we very well may need right now. Let's turn it on to 100. And let's go ahead and crank this up because this is polycarbonate. And we have to make sure that I can cut through polycarbonate. And can I use this to fix a polycarbonate print that has gone wrong? So let's see if 350 will cut through polycarbonate. Yes, it will. There you go. Not all the way through. I should have kept it on there just a little bit. A little bit longer, huh? Not quite. There we go. Alright. And of course nylon. Nylon should cut at 350, no problem. It's a much softer filament. Yep. So I expected that to cut no problem. A soldering iron made for 3D printing fixes errors, molding, creating joints, putting parts together, and seems to work very well. Very happy with it. I'm going to take this temperature down to about 250 now and turn it off so it can cool down. Now you saw how long I've been doing this. I've been working at this for a while, and yet this is all still very cold. I wouldn't call it cold, I would call it warm. This is all warm here. This is not hot at all. I can touch around here really easy. Now this actually is just warm. Now if I hold my finger there for a few seconds, it will burn. So stay off the metal. Keep your hand back here. The grooves are meant there for a reason, for your finger to fit in the groove. Left hand or right hand. So either way, that's why they have the grooves there. And keep your finger off that metal and you'll be fine. It's a very nice little tool. I like it. I forgot to fix. Can't believe I forgot to fix this. I broke it on purpose so we could fix it. Well, Yoda took longer than I thought. So I'll blame it on Yoda. Always remember to unplug the unit after you're done. Please give it plenty of time to cool down. And remember, these tips may be hot as well if you've been doing hot swapping. The hot swap seems to work really well. Well, I hope you enjoyed the review. I want to thank SRA-Solder for sending me this unit for demonstration, reviewing, and giving me the opportunity to test it ahead of time. And I want to thank AU3D, the AU3D department of the Ritocco. Is it Ritocco? I'm not even sure how to pronounce that. I'm not even sure how to pronounce AU. To tell you the truth, AU Ritocco. Anyway, I'm sure they had to put faith in SRA-Solder that I wasn't going to blow the whistle early on the product during the testing phase. So I want to thank them for trusting their distributor to give the product to a person that could actually assist and help and make the product better. Also, I like testing things when they're early releases and stuff. It's fun. And I make sure that they work before you guys go out and buy it. So what a way to fix this guy here. I thought it was going to be trash. Definitely an enjoyable little soldering iron for fixing 3D prints and plastic. If you like this video, go ahead and give it a thumbs up. Please subscribe for future videos as well. Make sure you hit notifications so you're aware of when I release new future videos as well. And keep on tinkering. Thanks for watching. Like this poor little guy, he printed out okay, except he's missing an eye. So maybe we can take some black filament and try to fill his eye in and repair him. So I don't have to go through the time it's spent to actually print this out.